Hello Internet. In this video, we are going to be working on improving our platforming character controller. And specifically, I'm going to be looking at how to abstract out a few things so that the specific controls of this character controller are handled outside of the character controller itself. So the reason we're doing this is a concept called inversion of control. And so right now we have this platforming character controller, and it knows everything that happens in the platforming part of the controller. The problem with that is that everything is tightly bound together. And so because everything is tightly bound together, if we want to write a test, we have to test the entire character controller, and that is difficult. It also means that it's really hard to continually add new things because we're constantly stacking all of these behaviors on top of one another. And that isn't always the easiest way to do that. So the idea of inversion of control is you have something that requires things. So if you think of your car, for example, your car requires wheels and it requires a motor and things like that. But as long as those motors and those wheels fulfill a specific contract, like a size, a radius of the wheel, for example, it will work with that car. And the same thing is true for inversion of control inside of our game or inside of our application or whatever we're building. The idea there is you give it a contract, an interface or something that it's expecting, and you can use that. Typically, you would use something like Zenject to do this. And I actually have Zenject in this project. We're not going to start there. We're going to start a little bit more basic, and we're just going to do it like the most absolute basic thing we can do. And then we will add as we need it. Right now, I think Zenject is a little bit of overkill for what I'm needing. And so we're not going to adopt it right now. But it should be easy enough to pull in if we ever actually need to take advantage of it. Zenject is a dependency injection framework. So I talked about inversion of control where you had these wheels and things. What that allows you to do is for your car to say, I need wheels. And for the framework, the dependency injection framework, to actually go out and find a set of wheels that exists in your world and apply them to that car. Without that, you would have to do that manually. And so that's sort of what a dependency injection framework does. In this case, we're gonna skip that part because that's extra work, and this will be interesting, I guess. I don't know how this is gonna go. I don't know how long this is gonna take or what's gonna happen because haven't done it, and don't know if it's a good idea or not. So that's why we're doing it. So we're gonna create a new character controller here. I have the platforming character controller. We're gonna leave that as it is, and we're not really gonna touch it. For this, we're just gonna create basic movement and all of this other stuff. So I'm gonna create a DI folder for dependency injection, just so that things are slightly separated. We'll be moving things around because that isn't really a good folder structure. It just removes it from the thing that already exists. So we're going to create our character controller injectable character controller. That's not a good name, but okay. So this is going to require a few things. I'm going to make this up as I go, and then we are going to figure it out. So the first thing it's going to have, like I said, making this up, so don't exactly know how this is going to go, but it's going to have a private float. Let's do a dictionary of a float. Does that make sense? We'll do iController state. All right. So what I'm trying to do, I should probably say that before I start just randomly typing types. I want to separate this off into state, so objects that handle state of our controller, and then also objects that handle other things. So we're going to have things that can control the state and things that act on that state. And then we'll probably have something that updates the state as well. I don't know if that's going to be a third thing or what. State provider. Let's do that. So the state provider is going to provide specific amounts of state, I guess, to our controller. I should point out this is going to change. There's no way we're going to keep this as it is. It's going to be modified as we need. I'm just doing this as a way to to kind of like get my thoughts onto this, and we'll probably iterate over this a number of times as we learn new things and as things stop working, or as we run out of ideas, or whatever comes up. It's kind of a living project, so we'll figure that out. I think I'm going to type this based off of the type. That might be a bad idea. But what I want to be able to do is to have specific state providers, and to have specific inputs require specific state providers. And so they're going to be able to say, I need the movement state provider that's going to control movement, or the platforming state provider, which is going to control, is the player on the ground or whatever. And this lets us kind of separate those off. And so we can have specific behaviors that only require parts of the state. And so we can introduce entirely new levels of state without having to modify the entire stack of everything. And the idea is it kind of fragments things off into smaller testable pieces that we can manipulate and modify without worrying about breaking the entirety of our game. At least that's the idea. A lot of what I'm focusing on here is making this really testable and really easy to use. And I'm not sure that's going to be very obvious, or if it's going to actually work, until we get further along and actually start testing it, because we don't have tests yet. So anyway, iState provider is just going to be our states. That was the longest introduction to writing a dictionary that I have done in a long time. Encapsulate field states and use property. What? That doesn't exist, and type doesn't exist. Why doesn't type exist? System.type. There we go. Let's just import type like that. So it's keyed off of the types. Again, I think that's a bad idea, but we're going to do it anyway. And then we're going to have a private list. Doesn't need to be a list. We can do a linked list. This doesn't matter order-wise. Well, it might matter order-wise. Priority queue? Is that a thing? Let's see. System, collections, generic. So there's a queue. I'm wondering if there's something that's already a sorted list. That might be what we want. And so the reason I'm looking for a sorted list is because I want these to be able to provide a priority. And that's going to allow us to have specific states that will execute before others. That's probably not going to be useful right now, so we could theoretically ignore it for now. But it might be useful in the future if you have like a jump that you want to do before something else. Just so you can actually work on modifying things. For now, rethinking that, let's just do a linked list. We don't need to worry about that yet. Linked list, this is going to be our action. Action provider. I'm getting concerned about using provider in this, but we're gonna just do it, and that's gonna be our actions, and then we're going to have an private linked list of state modifiers. So the thing is we have a state provider already. I don't know if we need a state modifier. That doesn't seem like it's useful because the state provider will already be able to provide a state. So you don't need to modify it because it should already be there. So I think we're good here with just those two interfaces. All right. So iAction provider is going to provide some sort of action. And so the idea here is we're just going to do for each var action in our actions, and we're just going to act on that. So we're just going to do action dot execute act, and we're going to give it the set of states so it can actually read the states. And then we're also going to give it what? Do we need to give it anything else? So what we can do what we can do here is actually have our action.states. contain information about our character controller. So for movement and stuff, the states themselves can actually control the movement. So we don't need to update, we don't need to actually provide our game object to that. We can actually use a state to track that and have the state handle moving it. And so the advantage of that is if we have our action say move X5, then the state provider that is actually controlling that, whether it's like moving without physics or moving with physics, is actually controlled by the state itself. And so actually modifying that behavior becomes, it happens in one spot. And so we don't need to modify every action to use different modifiers to do that. We're just saying, we expect you to be here now. And the state provider is going to say, okay, here's how I'm going to get there. And we can actually do it that way. So I think that makes sense. There's not anything else that I think we need there. None of these are initialized and none of them exist. So that's the next step. For now, these will eventually be split off into separate things, but I'm going to do this here for now. So public interface of iStateProvider. And this is going to be a generic thing. Do we want this to be generic? If we make it generic, I don't know how we make that work. That might be annoying. Because there's no, because of the way C# handles generics, there's no way to do like a question mark here. So if you're familiar with Java, you would do like a any type. Because of the way Java handles generics, this is valid, but it's not valid in C# because the compiler actually identifies what type it is and injects that for you. And so because of that, we have to actually explicitly declare a type. We could do like object, but then it's not useful. So we're just going to do iStateProvider, and it's going to expect a type. This has some issues. It means we need to actually cast things out. This would be handled by a dependency injection thing. You would be able to say, I expect iStateProvider to get me things, and it would be able to do that. Effectively, what this whole thing is doing at this point is serving as our dependency injection framework. We'll be able to make that better later. The action provider here is going to act on things. This one we know a little bit more about. So this is going to do a void. What do we call it? We called it act. And it's going to expect a dictionary type of types and iStateProviders. And so that will be the states. And so it can do lookups and say, I expect this specific type, and then it'll have to cast it back out, and that entire invocation is going to look gross, but it'll be fine for now. We're doing this all here, but all of these can be separated off into separate classes. There's nothing preventing us from doing that other than just, if it's all in one spot, it becomes a little bit easier for us to see. So iStateProvider, we need to figure out what this is going to do. I don't know if we need to actually give it anything here. Because all of the behaviors are going to be different. So I don't know if there's much that needs to happen there yet. So we're just going to leave it, and I'm not going to try to add things there. Then we need to actually provide implementations of this. So what I'm going to do is do a public class. Again, doing this all in the same file. There's just because this way we're not creating a whole bunch of files that we're going to be deleting and having to manage. This just makes it a little bit easier for me. So we're going to do a movement input provider. And that's a iStateProvider. Movement state. That, sure. Why not? This already implements it. So all we need here is two things. So we're going to do public float of horizontal. And that's going to have a getter here and that's going to be input.get axis of horizontal. And now there's no setter here, but that's fine. This is going to be our vertical. And so that's going to read in our input and just give us a horizontal and a vertical input. Again, this isn't going to be our entire character controller here. We're just trying to do the basics here and actually get this to some working state that we can iterate on and make it better. So the advantage of doing this, the reason that I'm writing this the way that I am, is because if we ever want to replace this and plug this into something and say, let's do class movement mock, for example, we can extend this and say public float horizontal is actually just 1. And what this is going to do, we need to override that, I think, right? Can we do override properties? We need to make this virtual if we wanted to do that. But what this is actually allowing us to do is I just created a class that is always going to move right. Horizontal will be right in this case. So we've effectively just created something that always moves us right. And the advantage of that is we can create constant things that are always going to provide us with expected values. And so if we're testing this, for example, we have concrete inputs, so we'll know exactly what the input is without having to actually run our game and test it. So this gives us a way to abstract that out. So that is our movement provider. And then we just need an action provider. So public class movement action. And that's an I action provider. We could probably do some interesting things to improve this. So what I'm thinking is this could have a set of states that it expects, like that. And then we could actually just remove the dictionary and have the character controller handle those injections. We're not going to do that yet, but that's a possibility. I action provider is there. It needs to be implemented, so we're just going to do that. And so what this is expecting is a var of a movement state, movement input state provider. What am I doing? There we go. So this will be our state, and it's going to be equal to our states.get. I guess we can do it this way. And we're going to do type of movement input state provider. Again, this is going to be really long and gross. That's sort of expected, unfortunately. But that's sort of how this is going to work. So state provider. This whole thing, we can shorten later. I'm just not. And also, I should point out, this will fail if we don't get an input. So this is a hard failure if we don't do that. It will throw an exception and everything will crash and run really slowly. That should be all right because we're expecting it to exist. And I'm actually going to explicitly say this exists down here. But that's sort of the idea. So state. We need to do state.horizontal and vertical. So we just need to act on this. So states. Why am I doing state stuff? Oh, right. Because we were going to have the states control everything else. We actually need a public class player position state provider, state provider. And this is actually going to provide our player position. So virtual transform. Do we want it to be a transform? It can be a transform for now. Actually, since we're doing this as explicitly as possible, we're going to boil this all the way down to position. So private transform. We're going to store the transform here of whatever object that we're going to be modifying. And then we're going to have some sort of public vector3 position. And so this is going to have a getter that's just going to return the transform dot position. So we have a way to get our current position, but we also are going to expose a setter that's going to say transform dot position equals the value. And so this gives us a way to move our player. but we actually need to grab that. So we're going to need another one of these lines. That's kind of gross. And you can kind of see where some sort of injection framework would be really handy to help manage this. So we're going to name these something useful now. So movement and player, position probably. And then we just need to actually move them. So I don't have any way to inject a speed or anything yet. We would just need another state provider or something like that. So we're just going to do position plus equals vector3 dot right times our movement dot horizontal times the time delta time. And then position plus equals vector3 dot up times the movement vertical times the time delta time. And it doesn't like this. Oh, position dot position. Okay. Maybe not the best name. But there you go. So this is actually going to modify the position of our object based off of these things. The only thing we need to do now is actually define these. So we're going to do that by doing this. I'm going to use a dictionary constructor here, which is going to just look like this. We need a movement input state, something like this. I talked about inversion of control. This is not inversion of control because we're explicitly saying in our character controller what it expects. This is just abstraction. So we need to create the objects too. So a new movement input state provider like that. And so that is that. Why doesn't it like this? Oh, that's not going to work. New dictionary of that. There. So there's the new dictionary constructor. It's inside of these curly brackets, and then you just do a curly bracket and then key on one side and value on the other side. So we're going to do that. I have a video on this if you want to dive a little bit deeper into that, but this is the crash course. We're just going to get this done. So those are our two states. We just injected the two states, or explicitly defined the two states, I guess. That's probably the better way to term that. And we're going to create a new linked list. Again, we're using a linked list here because we don't care about state. We just need to iterate over this. For the most part, it doesn't matter. We're gonna have the same thing happen, regardless of if we use a linked list or an array list. But if we ever need to inject additional states, a linked list would probably be better. And so because of that, we're going to do a linked list. The actual advantage is not really there. It's just me doing things. Let's see here. We need a movement action. So this is going to be a new movement action. And there we go. One thing we can do, accepting it first. What? Does not contain a definition for add and no accessible extension method add. Okay, why not? Okay, that's weird, but we'll just use a list. I went on that big rant about linked list for nothing, apparently. That's okay. So linked lists have an NQ and a Q or DQ, I think, functions. I could be wrong, or it's like add last, add. Yeah, it's one of those. It's not what the this constructor is expecting, and so we have to use a list or something else that implements the constructor that it's expecting. So just because it didn't know what it was. We have to do this. What we can do here is actually provide like a speed. This won't be exposed in our inspector because of the way we're doing this, but it's there. So we could say like 5. And then what we would need to do is create a constructor here. So private float speed, and we're going to do public movement action. And we're going to have a float speed, and that's just going to say this dot speed is equal to the speed. And this allows us to inject specify additional values here using a constructor. it's maybe useful. Probably not going to actually end up using that. There's other ways we can inject things, but this will be fine. So theoretically, this works now. So this is what our character controller looks like. It just defines a bunch of actions and states that it uses, and then those actions consume different things and then update the state. And so this is very long, I guess, for what it's actually doing, because it's really just taking, it's just modifying the position. But the advantage here is that I can actually modify like the position, so I can actually have things that will track if the position is moving, or condense all of the player position updates into one movement, and then do that all in a big bulk move at the end, or whatever else I want to do. And like I showed, we can also abstract out like inputs, for example. So this gives us a way for us to replace, say if we have a controller and we're using a controller, we can swap out that controller with a virtual programmed one that will do whatever we want. And that's useful for either like playing back specific inputs, or also in this case, we're going to be using that as a way to just modify how our game works. So we can actually write tests for all of this. Because I could, for example, provide a horizontal movement and then check that the position is now greater than what its previous one is, or that its position is now a specific expected value. It gets a little bit harder because we have this time here. We'd probably want a state provider for the time as well, just so that we can have specific time intervals specified. But that's more just a testing thing, and we're not writing tests at this point. So theoretically, I should be able to insert a cube right there. Why is this locked? What the heck? There we go. All right, so we have our cube. Let's put it at 0, 0, 0. And let's add our injectable character controller here. And now, hopefully, there's two character controllers now, so this is going to be a little bit weird, but we should be able to move this cube. If I press things. Nope, didn't work. We have an object reference not set to an instance of an object here. What's going on? Oh, our transform. Our transform is never set. We're never assigning this, so we need to do that. So public player position state provider, this thing. We need to provide a transform here, so that we can actually move our player, because we didn't have a way to do that. So this transform equals, not that, equals transform. And so this will allow us to provide a transform into our player state provider. And so we just need to do that. The problem with that is we're doing it here, and I don't think we have a way to get what we need here. So we're going to move this like this, and do a start void start. We could do this in the awake too, probably, but we're just gonna do it here and say states is equal to this, and we need to provide our transform. So this dot get component of transform. So that should actually provide the transform into our dictionary, and everything should be good. We also did not need to move the entire dictionary initialization down here. I did because this way it's all in one place, but we could have just moved this line here and done an add and modified our state so that we had additional things. One of the other advantages of designing it like this is if we want like temporary modifiers, for example, that will adjust the player state or do other things, we can just add actions or add states, and things will read them and do their thing. And so we can actually use those as game mechanics. Whether that's actually a good idea, I don't know. Never tried this before, but we're gonna see. So if we play this now, we don't get any exceptions this time, and I can move. So this is, I guess, the basics of doing this. There's much better ways of doing this, but what we're going to be exploring here is how to write tests for this and how to do other things. And then we can actually figure out if this is a good idea or not. Because I still don't know. But hopefully this kind of gives you some idea of like some of the abstraction patterns that I use and some of their advantages. This might seem like a lot of work initially, like when you just look at this. The question is, why would you write 75 lines of code when you could have written like 8? And the reason there is that mostly testing. Testing tends to add up when you're writing code, but the advantages of testing are, if I ever need to come back to this, I still know it works. If I need to change something 6 months from now, and I want to know if my game still works after making that change, when I have tests over this, I'm less concerned that I just broke my entire game, because I have things that are actually automatically going through and testing and making sure that when this value is equal to this thing does that. And if I don't have that, I have to manually go and validate each of those specific steps, and it's tedious and annoying and very prone to breaking. This helps create a system that makes it possible for us to avoid those kind of things, because we can actually just plug in what we want and actually write those tests. And then really the difficult part is testing the integration of all of these systems. Like, is our input actually configured correctly? Those things are less easy to test, but the actual integration of the code that we're writing becomes a lot easier. So that's, I guess, the motivation here. But I will leave that here. This is pretty much everything that I wanted to cover in this. There'll be a separate video where I'm just going to write a test that covers this. That'll be a separate video, and we'll probably inject the time like I had mentioned before. But that should give us a handy way to actually write tests for this. So that is the next step, and then we'll look at making this a little bit better. So if you want to see that video and you want to stay tuned for everything that we're doing with this platformer and what's next, consider subscribing. If you like this video and you're still here, maybe consider giving it a thumbs up. That actually helps a lot. I use that to determine what videos people like more than others, and what areas I should be focusing on. It kind of helps shape the content on the channel. So if you want input there, that's probably one of the best ways. Otherwise, leave a comment and let me know what you'd like to see, or anything you're working on, or if you have any questions. But that is it for now. So I guess until next time, see you, Internet.